this question, we are given a function. We are told that f of x is equal to max of x square plus 2x plus 1 and modulus of x plus 1. So we have two functions. The first one is x square plus 2x plus 1, that is essentially equal to x plus 1 whole square. And the second one is modulus of x plus 1. The value of f of x is the maximum of these two. And we are looking for the minimum value of f of x. The easiest way to solve these kind of questions is to first draw a graph of both the functions and then try to figure out at what point does the function f of x actually have its minimum value. If you're trying to draw the graph of x plus 1 whole square, let us first draw the graph of x square. So if you're looking at x square, if this is the y-axis and this is the x-axis, if you're looking at x square, it will be something like this. It will touch the x-axis when x is equal to 0. This is the graph of y is equal to x square. You are looking for x plus 1 whole square, so it will look very similar, but instead of touching the x-axis at 0, it touches the x-axis at minus 1. This is the value of x plus 1 whole square. This will be minus 1 comma 0, and it touches the y-axis. It intersects the y-axis at what point? At that point the value of x is 0, and when x is 0 the value of x plus 1 whole square will be equal to 1. So this point is equal to 0 comma 1. So if you're drawing the graph of x plus 1 whole square, it will look something like this. This is the y-axis and this is the x-axis. It will look something like this. This is x plus 1 whole square. It will be symmetrical around the point minus 1 comma 0, and it will intersect the y-axis at 0 comma 1. Similarly, if you are looking to draw the graph of modulus of x plus 1, let us first draw the graph of modulus of x. How does the graph of modulus of x look? You again have the y-axis and you have the x-axis. The graph of modulus of x will look quite similar. It will be symmetrical. It will be symmetrical around origin. So it will look something like this. It will come to 0. It will come to origin, and then it will again start going up. And the graph of modulus of x plus 1 will be just shifted up by 1 unit. So it will look something like this. This is how modulus of x plus 1 looks like. Again, it is important to note down the important points of this graph. Where does the function attain its minimum, that is modulus of x plus 1? This will attain its minimum when again x is equal to 0 and the value of y will be equal to 1. So the function modulus of x plus 1 will look something like this. So if you're looking for the function f of x, which is maximum of x plus 1 whole square comma modulus of x plus 1, let us remove the function which is below the graph. So this will be removed and this will be removed. So the function will look something like this. Initially, for some time when x is much less than 0, it will essentially equal x plus 1 whole square. For some interval, it will be equal to modulus of x plus 1. It will again equal y is equal to x plus 1 whole square after it crosses the y-axis. So the function f of x will look something like this. Just to remove any confusion, this is y-axis, this is x-axis. Initially it will be y is equal to x plus 1 whole square. Then it is going to be y is equal to modulus of x, and after it touches the y-axis, again it will become equal to x plus 1 whole square. And the minimum point for both of this is the same. This is at 0 comma 1. Therefore the minimum value of f of x is equal to 1, and this will happen when x is equal to 0. So the correct answer is 1. That is the minimum value of f of x.